Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we look at application development and management at scale. Now let's get to the show. Alex Williams here of the New Stack, here for the New Stack Analyst Show, and my co-host Donnie Berkholz.
Howdy.
And Mitchell.
Hello.
Mitchell Hashimoto, and we have Kelsey Hightower.
Hello.
Good group. Well, thank you guys for joining us. Mitchell, this is your big event here, HashiConf. It's your first, right?
That's the first.
And why'd you choose Portland?
Well, Portland's pretty cool, first of all, but we chose it because San Francisco's pretty expensive. We have a lot of community up in the Northwest, and we specifically chose the West Coast. Also, we have a lot of international people that in Japan that we wanted to get over here. So the criteria was West Coast, not San Francisco, because we could put up a much higher quality conference with the money we save from being in San Francisco, and we picked Portland.
Nice.
And it's worked out really well.
Nice.
Sold out in 6 weeks, so it wasn't hard filling the place.
So give us a recap of what you guys have announced today.
A recap. All right. Yeah, we announced a few things. We have some big releases for console and Vault. Some really big features there. Vault's audited, which is a big deal. We also announced a new product, Nomad, which is a scheduler. It can schedule containers, can schedule static binaries, Java, VMs as well. And then we announced Auto, which is our successor to Vagrant.
Great. So tell us about the scheduler in particular. I'm curious about it. Why did you guys decide to launch a scheduler, and why did you make it as encompassing as you did?
Sure. I think it's obvious to a lot of people that you need a scheduler at some point, and we felt that as well. We were reaching a point where a scheduler would help us a lot.
What were you using before?
No, before we were just we were just doing manual, human bin packing. Yeah. So putting, we were even endorsing one app per server, like things like that, keeping it simple. But at a certain point, that becomes expensive, and so we wanted a scheduler. And we looked at the ecosystem out there, and we just weren't really happy with operational simplicity, how easy it is to use. We just wanted something better in that category at the least, and so we decided to build it.
So what are you guys seeing in the scheduling world? We've been talking a little bit about schedulers. We had a chat about it at Software Circus in Amsterdam, and kind of the semantic nature of schedulers and how they're really kind of they're starting to have a real interesting role. What's your view, Kelsey?
I think it's just a natural progression of what people were doing already, right? So if you think about configuration management, was basically automating, as most people have been doing with their scripts, automating more of the reporting side and giving a full solution. I just look at schedulers as automating what ops has been traditionally doing, but having something that's fully automated, that's online, lets you do things you just couldn't do by statically scheduling all of your workloads either in the spreadsheet or in some inventory file with your CM system. So I think it's a requirement, like Mitchell was saying.
Yeah, I guess I see it. I agree with what you're saying. I see a little bit of a parallel in that. Probably 15 years ago, I used to do high-performance computing, and what I see now happening in big data, and now more recently with sort of the container revolution, is exactly the same ideas being re-implemented. And that you've got, schedulers were a big deal when you got high-performance compute clusters. You want to eke out every last drop of dollar there. And you're like 3% change in efficiency when you've got 100,000 nodes is a pretty big deal.
Yep.
And so, we used to have ideas like PBS, like Torque. You would even have meta schedulers on top of the schedulers to make sure the schedulers were scheduling efficiently. And, one of the sort of last ideas that came out of that world was this thing called Condor, which would sit on desktop workstations, use up extra compute time, make sure you get 100% compute use, which is sort of come back in the form of things like SETI and things now like Mesos and like Nomad, right? Of how do we use up all that compute, and what's that next generation of ideas going to be now that everybody is thinking about that level of scale, and it's not just limited to people spending millions of dollars on custom clusters, or not just limited to more recently like web companies like Yahoo and Google, where things like Hadoop and like MapReduce came out of.
So I think if you say why now, since these things are pretty old, why now? Because I think in the high performance computing world, there was this concept of a job. You know what its parameters were, you know what its boundaries were. And I think we're starting to get there with applications really in the form of this container thing, where we start to say, let's just scope this down to something we can actually manage and describe. If you talk about existing workflows for an application, it's like, hey, you run this set of scripts on that server, and then it will work. But now we're starting to say you can actually describe an app in a jar as a static binary or as a container. It's much easier to use a higher order system that isn't concerned with the details.
So where did you draw your inspiration from for this schedule?
For Nova?
Yeah.
We took a look at the high-level features of existing schedulers in the space, but as well as just looking at the same research I think that every other scheduler looks at.
And when you say in the space, do you mean just the ones that have come out super recently, or do you mean like a broader view of schedulers? Like
I would say the past decade.
BMC's got Control M, and it's been around for a long time.
We didn't look at this. Yeah, we didn't look at those ones. We didn't look at IBM stuff. I think more of we looked at Kubernetes Mesos. We also took a look at the Borg papers, Omega papers. I would say past decade, and not like mainframe scheduling.
What did you see in particular? I mean, if you broke it down, well, what were you observing about Kubernetes, for example?
I think that every scheduler is doing a really good job right now of following the research. Like we looked at it and said like they're doing a pretty good job of keeping up with state-of-the-art research, and so at the same time they're pretty hard to set up, pretty hard to use, and also we saw a lot of focus on Docker.
What are you seeing is difficult to set up?
For example, Mesos requires Zookeeper. Setting up that on its own is not trivial, and so we wanted to sort of ease that transition.
What's happening to Zookeeper these days? Is it falling out of vogue? I keep hearing people talk about Zookeeper,
it's all about operational complexity for Zookeeper, and that everybody I run into says like, hey, we built this app around Zookeeper because we did it before there were things like etcd and Consul around, which are both a lot easier to use and get up and running and be successful with. Or they'll say like, hey, we've already got Hadoop rolled out, and so we've already got Zookeeper. We already know how to maintain it and run it, and so we're just going to keep doing it that way. Yeah. But for greenfield implementations, people are looking for something easier.
I think a lot of people to Zookeeper's credit, I won't necessarily defend it 100%, but I think to their credit, so many people that were exposed to Mesos because someone else was using it also brought it in, and they just didn't understand the type of system Zookeeper is. They were trying to treat it like Redis or Memcache. And those are just different systems. So a lot of people just wanted it to work like Memcache. It's like, why is it important that I actually keep, my consensus group in place? Why is latency mattering all of a sudden? And I think a lot of people just found that hard because they had to think in those details, where some of these other systems that don't provide the same consistency model, you don't have to think about those things, and most people just kind of punted that to just, not my problem.
So tell us about what makes the scheduler easier. What is it? What have you guys done? What have you guys tried to do to make it easier comparatively to others?
The big thing we've done is just eliminate all the dependencies. So it's a single binary, and it's the only thing you need to get started. So you just run one binary, and you can immediately start sending jobs to it. For production workloads, it follows the same console model of how to bootstrap it, which is very simple now.
So what are you putting behind the curtains then? What is it that you're
Sure, it's built on everything we learned from Surf and Consul. So projects that have existed in production for, I guess, over a year now, over almost a couple of years, and just building on top of that.
Now, I guess one thing I've been wondering about reading that, saying like, hey, we built on the same algorithms. Are you reusing the same code base at all? Or you just rewrote it?
It's all the same code.
Okay.
So which is really interesting, because as Surf gets better, as Surf gets higher performance. So for example, Surf just got all this network tomography stuff that we announced at the conference. We actually have that available in the scheduler, and so you'll be able to do things like, I want this job to be close to this other thing, and we can figure that out really efficiently.
And you say network tomography, that sounds like a CAT scan or something. What does that mean?
Well, the formal definition of tomography is basically measurements and mapping using measurements. And so
mapping using measurements.
Yeah, and so network tomography is mapping your network with measurements, and that's what we do.
Okay.
Because we hear about tomography, right? I've heard tomography.
Yeah, tomography.
Tomography, yeah, it's kind of a medical term, and so that's why I was like, what do you mean when you apply that to the networks exactly?
Yeah, we didn't make that. I mean, it's a very, that's how they describe it in research and stuff, is tomography. Yeah. We use that word specifically because for the people who would know previous systems that did something like that, it would mean something.
Yeah, so you see a lot of like network monitoring companies doing something like this, and something we're starting to think about is understanding what the network structure looks like compared to what the server structure, the container structure, and the application structure, and sort of the logical business structure look like.
Yeah, I think if
we're talking about what people really care about is like, I'm a company, and you know what, people are trying to like check out on my e-commerce site, and that's the only thing that really matters.
Yeah, if we're talking about network tomorrow for a second, I think the coolest part of it, especially with regard to a scheduler, is that is that you don't. A lot of other schedulers, you need to program in things like these are on the same rack or these are close to each other. Like it's manual humans putting that in. And with the tomography stuff, we actually have the real data, like the truth. And so even if you misconfigure a router and suddenly make the same rack slow somehow, we'll figure that out, and close will no longer be the same rack. We'll actually correct for that without operators coming in. Hopefully have alerting to figure that out as well. But it's kind of cool that the tomography is the source of truth. Like it just is the truth. It's not pre-programmed or anything.
How long does it take to learn the network structure?
It stabilizes within a minute.
Okay, it's fast.
It's very fast, yeah.
So you did these. So tell us how else you try to make it simple and usable for the end user.
The other thing we try to do is more on the user side, the job specification format. We took a look at other formats, and they're just a little too low level, and so we tried to just make it.
What do you mean?
If you show it to a developer, there's just keys in there that don't make a lot of sense. Like what is I can't give. Well, a good example is like what are the container namespaces you need and things like that. Like that's so low level that we didn't want to do that. So we just tried.
Where
to
do you
bring
have
it
to do that?
I don't want to say. I don't want to like.
That's fine. Is it Kubernetes?
It's not Kubernetes.
So Kubernetes is very similar to. So some of the research, if you look at their tasking, comes from like Borg's probably the biggest influence there. And so Kubernetes definitely has enough abstractions there where you say, here's the mounts I want, here's the containers I want. But yeah, there's other systems that just basically reflect the thing that they're deploying to.
Yeah.
Right? So if you look at a system that says it was...
And so we're sitting here thinking we've been talking about 3 schedulers, and we've mentioned 2 of them now and said they're not the one.
Well, I mean, if you look at Swarm or you look at Meso, sometimes you do start to leak some of the details depending on the interface because those things were meant for one particular usage, right? And I think with Nomad, they're assuming that you're going to have containers, you're going to have static binaries in Java. You can't leak as many of those details, and there's really no reason to at certain levels. It's just not that important.
Yeah, and we give pretty low-level knobs in that Java specification format, but we just wanted it so like if a developer gets started, they could just point back, this is my Docker container, just run it, and we have defaults for everything else, and just go with it.
Right. Now, something I'm curious about. I mean, I know you don't want to sort of talk bad about competitors or whatever.
Yep.
But your documentation is pretty famous for really laying out like where do we stand relative to other options.
Yep.
And so I'm
we
curious.
Did it there.
I mean, from the perspective of Nomad, since that's what we've been talking about, like how do people choose which one is right based on the sort of pluses and minuses of each?
How do people choose? I mean,
because we've been talking a lot about ease of use, but there's more to it, right? I mean, once you got up and running, then there's like, what's that experience like once you're an expert?
Yep, and I think one thing Armand mentioned in the keynote is when we design something, we design it for 3. We try to do three things exceptionally well, which is user experience or developer experience, operational simplicity, and then building it for scale. And I think that Hashicorp products in particular excel because we try to excel at all 3. And there's a lot of other systems trade off one of those. And so we did lay out the versus other things on the Nomad website so they could read that. But I think ultimately that's why they'll. I think you come to the website and you choose it first because of user experience of getting started. Then you choose it second because of operational simplicity, and then you finally just dedicate completely to it because you realize it scales.
Yeah. So I'll spice it up some. So I think Nomad over time will look like Kubernetes. Full stop. I think you're going to end up saying you're going to use console for service discovery. So there's another piece. And then you're going to use something else for like logging or being able to introspect the actual workload that you pushed out. This is a big part of these systems to be able to introspect a running workload. So I think you're going to end up adding those things over time. I actually played with Nomad last night, right? Mitchell was nice enough to give me access. And it is easy to set up, right? You say, look, maybe for most people where they're coming from, they don't need the complete system. They literally need something that will just place workloads in their cluster and say that's small they may ever need. So I think Nomad gives you that out of the box. You can just look at it and it doesn't present these other things to you day one to get started. Kubernetes presents them all to you. It will say, there's a networking model, it's how service discovery works, it's the full system.
And I'll add to that. I mean, he's right. Kelsey's right. If you want service discovery, you'll have to install console. The thing that is unique about Nomad is it automatically detects if console's there. Not 0.1, but this already exists and we're working on it. It'll detect console there and automatically register services. The next step we're taking is Nomad's going to know how to install these things. So for all time, the only thing you will have to install is Nomad. And then if you want service discovery, we'll start scheduling and bootstrapping these other systems automatically. Because we have the deployment tools. It's like, please enable console, Nomad will do it.
So it's really going to be like a full service catalog, and then presumably Atlas is going to have some kind of fancy GUI on top at some point.
Yeah, we've already built some pretty cool visualizations.
So before we move on to Auto, because I'm curious about that, would you add anything else about Nomad? Like that is built into it to make it more usable?
It's definitely more usable, and I think that one thing that's really unique about it is just its the execution drivers. I think that's going to end up being a really big deal. I think Docker's huge, and we first class support Docker. It's the one we recommend right out the gate. But for simple Go binaries, for Java places, and C Sharp's coming in the next release for .NET, like things like that is going to make it really nice to have one system for these heterogeneous workloads.
So I will vouch for that. So in Kubernetes, there have been times where I write a lot of Golang, static binary. I'm just forced to make this 4-line Docker file so I can wrap it in a container. And there are just times where it's like, well, just take this binary as is, and then just run that in secrets and namespaces. And that's currently being done. And I think run C is being used to do that. So I was I was building the app that knows that this is probably one of the first real uses of run C that most people thought run C should be doing. I think this is like a perfect use case for it.
Can you remind us what run C is?
So run C is, so Docker decided to come out with OCI standard, like a standard runtime for containers. And the idea there is to separate the image format, like what a thing is, to how you run a thing. So in OCI or in run C, the idea is here you have a root FS, and if you have a root FS, you can add a config file to say what parameters you would like, CPU isolation, memory isolation, namespaces. And then another tool like Nomad can come in and drop that binary in the root FS, create its own config, and then place that whole workload in the container without necessarily adopting the Docker daemon or even the Docker image format. That's not what you want to do.
Right, and that's actually something that got me thinking. See, we were just talking about isolation, but if you're sitting there running Go binaries or jars, that clearly affects the security model and the way you're isolating different jobs. So how do you think about that?
So we it's basically two or three, they overlap models of security with Nomad. So if you use a static binary, we use run C, so you get the normal Linux container security. When we support .NET coming out, we're actually going to not use the Hyper-V container stuff, which we will support, but if it's just .NET, we'll actually use the tuning with .NET to restrict memory, CPU, and also syscalls that Windows just has to restrict permissions. And then things like Docker, of course, you get the full Docker container and how they set it up. And then you can do full-blown VMs. So for some of the early adopters we're working with right now, the example we also gave in the keynote is we're recommending running Vault in a VM because you get the full decade plus of security in a VM. But with Nomad, it could run the VM and right alongside it run a ton of containers, right alongside without overcommitting resource usage.
Got it. And can you stack them up a little bit too and say I want this logical group of containers inside this VM and this one in a different VM?
You could do that. For the VM, you have to give the full VM to schedule. It won't place something in the VM.
Okay. Can you do nested Nomad?
You can. We haven't documented it, but you can. Yeah. We haven't done it, but since Nomad's built on top of that console architecture, it's built to expect Nomad agents to come in and out really dynamically. So if Nomad's launching a VM, which then launches Nomad, which joins, which can then run a job, you could do that.
Go ahead.
I was just thinking, I just wrote a piece, I guess it got published last week on what VMware was announcing at VMworld, right? And they're trying to take that dual-pronged approach of, hey, you can have this one-to-one VM container model, get all the security, every container super isolated, you have the decade of experience, whatever, or you can do sort of the hot new stuff.
Is the one-to-one model, when does that make sense?
Dependencies mainly. I think a lot of people went to this model because of one Ruby version will conflict with another, or your gem dependencies. So the easiest thing to do at that time was just go strength the VM to the resources you need, and then you get some dependency isolation. Containers just give us a better way of doing that, or statically linked binary just removes the problem altogether.
Yeah.
So dependencies, I would say, just sort of the security approach of, layers of defense, where if you have every container that has VM level isolation, you are a little bit more secure than you would otherwise be. You do have a little bit more overhead, but you are a little bit more secure. And every time you can kind of cut down on knowledge and accessibility, once people are inside your network, the better off you are. So that's, the modern security stance is assume they're already in, and then what? Right? And that's why Google, for example, has their HR software on the public internet now. so that they can think about what does it mean when everything you've got is exposed. Because they've already gotten, let's say, unpleasantly surprised when people found out that none of their internal traffic was encrypted.
Yep.
Remember that? Hack probably 6 months or a year ago now. And so, the new security model is like everything is external all the time. Now what? How do we add enough isolation around every microservice, around every container, so that once they hack one, they don't automatically get the rest? And that's why, certainly you put Vault in VM, but what else? What can get at Vault, for example, and how can you protect that?
So, moving on to Auto, tell us about Auto. Why did you decide to, upgrade Vagrant in the way you did?
Uproot Vagrant? Is that what
Upgrade.
Upgrade Vagrant.
Yeah.
Well, we took a look at sort of like what I said in the keynote of how Vagrant can be improved. I think we've made a really good ops experience, and the developer experience has been good, but we haven't focused on it in quite a while. So we decided to look back and focus on that, and to build it better. We thought we could build it better. So we built Auto as a successor to Vagrant, and we think over time it'll, for the majority of developers, Auto will replace Vagrant, but Vagrant will retain a lot of use cases that we're not targeting with Auto.
What I'm curious about is why didn't you just call it Vagrant 2.0?
There will be a Vagrant 2.0, and it's just a fundamentally different tool. Different configuration format, different commands. I think that the fact that it can deploy is just forces a just different architecture in the way things work, and it was easier to go this route.
So this is Auto is almost a new product.
Auto's definitely a new product, yeah.
And then Vagrant will have a new version of the legacy product.
Yep, Vagrant. Well, we're going to continue to release Vagrant releases for the next many years. Auto builds on top of Vagrant a lot right now. Pieces of that are going to slowly get replaced natively into Auto, but for now there's a lot of interaction there. I think it's going to be a multi-year process.
The thing that I've been trying to figure out, and I've seen people on Twitter curious about this today too, is where do Auto and Nomad fit in with Terraform?
So the idea
seems like there's some overlap.
Yeah, so the idea of all our tools sans Auto is that they do one thing really well, but they're very low level. So with Terraform, they don't abstract away the cloud resource service. You got to understand the infrastructure you're going to. With Nomad, you still have to manage Nomad, understand how you build something that Nomad can deploy and things like that. What we were trying to do with Auto was make all those decisions for you. So Auto automatically installs console, Nomad, Vault, configures them, uses them under the covers, and uses Terraform to do that as well. So the idea with Auto is that it's the easy on-ramp into the best practices development deployment scenario. And under the covers, we're using this production-hardened tooling that we've built for years, because why reinvent that wheel? So the overlap is that Auto uses those tools.
Okay.
Yeah.
So Auto now is like the meta orchestrator.
Yeah, the way we look at it is like as a layer cake is that Auto sits on top of all the other tools. Yeah, we're trying to raise the level of abstraction. I think one thing we noticed as well is we've come out with all these tools, and a bunch of other people in the industry have come out with tools, and they've made things better, but they haven't actually made things easier. Because to get a real production quality infrastructure, you have to actually learn so many complex tools today, like distributed systems, things that all have their own configuration format, their own collaboration structure. There's more to learn now than when you wanted to deploy like a LAMP stack 10 years ago. So it's gotten harder, I would say, and we're trying to up the level of abstraction so we can bring that back down and have everybody be using a best practices system.
What do you think, Kelsey?
Well, I don't know. I think, I talked to Mitchell earlier, it's like one thing that I was actually pretty proud to see is most companies are really afraid to disrupt themselves. Instead of sitting back and letting someone build a better Vagrant, they do it first. And that's risky in a way, right? Because then you get these questions of, well, should I even use Vagrant anymore? Right? And you got to fill those, but it seems like they're not afraid to like go and attack it straight up. Because if you were to build Vagrant today, you would probably end up building something like Auto. So it's nice to see that they're still thinking and not saying, well, Vagrant's popular, let's see how far we can milk it. So I think that's kind of like a pretty ambitious step and not afraid to pull it off. So I'm hats off to it.
I appreciate that. Yeah, Vagrant still has the most quarterly downloads of any product we have, and that's exactly right. We decided just to sort of cannibalize on
and the reason why I say this is that I've worked in many automation companies before, and I think one of the responsibilities those companies have, once you do get a community and a group of users, your job is also to move them forward, right? Your job isn't to just keep them on the same train that you decided to ship. You need to, like, if you see new trends, you're probably the best to understand their needs and give it to them first. So doing that with Auto, I think, was a perfect move.
So looking at, we have about 5-10 minutes left, I think, in the talk, in our conversation here. Some of the bigger trends out there, that you are seeing and that the people should be seeing in these new services that you're offering, the kind of the evolution of the container ecosystem, right? And moving more into like an orchestration, kind of a focus. You talked about microservices. Is everyone trying to move to microservices? Where, that's not something we would have really heard. Still don't really hear many people talk about it. It's become a hot topic. I'm just curious on.
Everybody is telling you how to do it, having not done it themselves.
Yeah.
You've got all these evangelists out there saying, like, let me teach you about microservices. I did one last night.
Yeah. Just curious.
Yeah, I think I've heard Kelsey, say it's a lot, but I think that what everyone's heading towards is, or what especially like companies like ours are trying to push people towards, is just like a Google quality or Netflix quality infrastructure. And I think that they've proven that you could reach incredible scale with incredible reliability using these certain architectures, and we're trying to bring those architectures and make them easily available to everyone else. And I think microservices is just one subset of that. I think another one's scheduling, another one's containers, actually. And so I think that's the trend we're heading towards. And I don't think people are necessarily pushing it. I think it's naturally just happening because one container show up. Docker didn't push containers on us; they just appeared, and people embraced them, and because they do help things. And so I think that that's just happening, and it's happening really quickly now.
Yeah, I think I'm one of the people that don't really talk about microservices at all, because I don't think most people are even equipped to understand what that means, right? But if you are interested in microservices, these platforms, Nomad, Kubernetes, will be soon the things you're going to want to look at, because if you're having trouble managing just one or two applications, your life is about to get real painful if you try to split that into 30. So I just think that these things are necessary, but I don't necessarily think you don't get any benefit if you're still if you believe that microservices aren't for you, you will still benefit from these systems.
Right. Yeah, and that's why I really like the sort of heterogeneous schedulers. Take your pick, because you can do the forklift style approach and then blend that with, let's say you're experimenting with microservices over here. You pick one of your applications through that. You've got 27 other applications.
Yeah, that's our core design philosophy, right? Is the heterogeneity. You said everyone. I don't think everyone at all is moving towards microservices. I think a very small percentage of people are moving towards microservices. I think it's the cutting edge.
I was paraphrasing one of the things you said. Maybe I didn't say it exactly.
I might have said
that. You didn't say maybe everyone, but you were talking about the kind of this movement to microservices.
Yeah, I think it's an undeniable trend, but I think that it's a trend being set by trendsetters right now, and that's not usually the majority. And so
I totally agree with you. I actually gave a talk at Blue last summer.
But we always
microservices.
say that. But we always say that. Then the world catches up eventually.
Exactly.
Well,
So I think that's why we've always built tools that we have Packer that could build machine images, even if like the trendsetters scoff at machine images. It's because there's so much of the industry still using them. We've always tried to build these tools that can be there for you, but then when you get to today, then they all still work. You're using Nomad, like the heterogeneous schedule. You're using Nomad to schedule your VM. Suddenly, you're starting to experiment with containers, and hey, we don't need to switch that technology out.
Yeah, I agree with you on the microservices front, because I was doing this talk last summer, and I was saying, so let me find some real examples of people who have done microservices in production, and their names are not Twitter or LinkedIn or Google. Let's find like a magazine publisher that's done it or something.
Yeah.
And good luck,
Yep.
I dug up a few finally, but you're talking like a handful.
Yep.
It's going to be a long time till everybody else gets there.
Yeah.
The other thing, I guess, so we were talking about what are the new trends we're thinking about, and the two that are on my mind right now, one of them is microservices, the other one is continuous delivery, which is, I think, a little bit farther down that road because there's a much smoother adoption pathway. Mm-hmm. I'm kind of curious, where does what you're doing here fit into that?
I think continuous delivery requires just an incredible amount of automation and trust and stability. So what we've been trying to do is, I agree, we're sort of heading towards that. And all our tools are sort of automating each of the pieces you need for continuous delivery, like launch infrastructure, install things, deploy things. If those things crash, then please move those things, like Nomad. And so and Atlas really is our continuous delivery tool. So I think that actually over time you'll be, with Atlas already today, you could get push and have that automatically all the way go out to production, and it's becoming more and more reliable with every tool that comes out. Not just from us, but in the space in general. Like containers were key to make this really easy.
It's my opinion now, it's how to sysadmins all the time. I say Bash, Golang is like the new Bash. Not necessarily because of Golang, but now your toolkit is a set of APIs. We're not screen scraping, standing it out from LS anymore. If you take these collection of tools that actually have documented APIs, if you start doing continuous delivery, it becomes a thing that you can actually pull off. Like doing continuous delivery 10 years ago, you're scraping output from random ass tools that never thought about working together. You're transforming basic output from XML to something the next piece of the pipeline can use.
Yeah.
But when that becomes all APIs, it just makes sense. You can build a whole new data pipeline. And I think then you'll be able to pull it off and interchange new things when they show up.
Right. Now, I guess if you're thinking about the pipeline, the thing that seems like it's missing from the conversation right now is testing, both at the application level and the infrastructure level. I mean, where do you recommend people fit that in? What should they be doing?
I think there's multiple levels of testing that are really important. We've tried to stay out of like the testing, like the Travis CI sort of stuff. We let that sort of happen, and what we try to do is be there before it heads there and be there after it's done with that, but just sort of let you choose. There's a lot of options there. So,
all right, so kind of an integration story.
Yeah.
This is my neophyte question then. So, if one of the promises you hear about Docker is that you can run something on your laptop, it's almost as the same as it would be in production. So,
let's be honest with this one. This is like, if I give you a DVD, if you still have a DVD player, you can watch it on your laptop, and it will be the same movie you watch in the movie theater. It's a totally different experience, right? If your laptop is crappy and slow, you're going to run that Docker container crappy and slow because it's all the hardware you have. If you take the same container, you throw it on a really beefy server and have a bunch of power, I guarantee you the experience and performance of that app will be different. So there's two parts to this. There's the image, and there's the actual execution environment. And one thing that is not portable, unless you have the exact same server in production connected to the exact same pipe, probably at the exact same location, you need to just have your desk in there if you want one-to-one parity like people play. I don't know if you can get it, but the image format does make it at least a little bit more reliable.
Yeah.
We're pushing the exact same bits in both environments.
I'll say it even more sort of like directly. I think that it works. Like it's certainly true. The container you Docker run on your laptop will Docker run on the server, but I don't think it's necessarily what you want, because what you want in development is going to have a lot of extra things in that container, and what you want in production is a more you want to compile things a little bit differently. You want to remove all the compilation tools and things like that, and that's something that just requires a build process that we're not really seeing out of Docker right now specifically. But other companies are certainly doing it.
Yeah, a lot of that fits into, if you look at some of the CD tooling that's come out recently, a lot of it builds in multiple steps for sort of promotion pipeline to prod, right? And at some point, you do reach that point where there is true environmental parity before you get to the point of like saying, hey, I'm just going to deploy this to 1 million people and see what falls apart.
Yeah.
And it might not be on the developer laptop.
I think people want predictability. Like if I say that I'm going to take this app and run it with these settings, I want to be able to get some predictable outcome. And if not, I want to at least be able to observe its behavior. I think that's the best you're going to get. We just are missing the ability to observe some of this stuff. Even if you're fully automated and you have no logs, you don't even know if it's actually running or working correctly, right? You're still waking up with pagers. So I think
it's like this I am robot world or whatever, right? Of like, well, they're automated and knows what they're doing. So they're
out there
doing it by themselves.
Those silly machines.
Yeah, that's why I always talk about like what's DevOps about, and we've got the filter aspect, and then you've got automation, and you have to have measurement.
Yeah.
Because without measurement, you can't know what the automation is doing, and you can't improve on it.
Yeah, it's actually really funny because everyone's getting so much better at building resilient systems now that they actually hide a lot of problems that are really happening. We had one big user using console happily for a long time, and then they finally decided to look, and they realized it was leader electing every 10 seconds on a cluster of like 5,000 machines, and it was working, but it was their latency graph was just increasing like every 10 seconds, and you just didn't know because it was recovering. But then once we were able to do that, where they were able to like lower their CPU usage by a ton, it's just funny.
So does this mean a new rise of like performance systems tools and such? I mean, is there a gap there with these tools?
I think there's a gap. I mean, there's not good tools for debugging microservices right now. It's a huge sort of plethora of different tools. Like we were just talking about this at lunch before this. Networks are not well understood by most developers right now, and network debugging tools are not well understood by most developers. And so you've got to currently at least build a collaborative debugging approach. It's not happening right now. In the absence of really sort of cross-cutting tooling, unless you really understand that.
Well, if I look at the patterns, like you look at HashiCorp, just pretend Mitchell isn't there, right? So one way is to say, what are the actual patterns that actually work? There's ideas, there's things that work in small settings, but then there's actual patterns that emerge, and then if you look at HashiCorp, like they're going to find that pattern, and then definitely going to give you a solution to it, right? Whether it's Packer for the machine images, whether there's Nomad for scheduler. I just don't think there's really any good patterns for this microservices thing that's going to be well-rounded enough to fit like the mold. People just do so many different things.
Yeah, we don't know.
We don't know yet. I mean, I think some things do leak out.
It's true with security policy around containers.
Yeah, I mean, there's some best practices out there, but I don't think you're going to buy something, drop it in your network, and say, "Yay, now I'm doing microservices." I mean, some things will help you. One thing I found that was really nice is something like Sysdig, but it requires you to do some analysis, and people don't want to do the analysis, right? They want the dashboard that says you're doing it right.
Right.
I don't know if we're there right now for
they want to move like
time.
a step farther up the automation pipeline with their monitoring too, saying like, oh, here's this problem, here's what caused it, here's what we should do. Would you like to do this?
Here's the last thing though. So one thing that's really weird in our industry, we want all these things, but we're willing to do zero change on our side to make it happen. So if I give you the thing that will help you, and I say you're going to have to rewrite 3% of your code base to take advantage, a lot of people are still forcing vendors to support bad decisions and old behavior and get all the benefits of doing it the best practice. I think most people are going to have to start to reconsider how much they're going to have to bring to the table to meet halfway.
Yeah, no, definitely. I talk to CIOs in that sort of crew, and they're often so focused on risk and not having a modern understanding of what that risk and the impact of risk look like, and they also haven't took the trade-off of risk versus agility, which is becoming a lot more important.
How much experimentation are you doing?
What's that word you said? Experimentation, you say? Tell me more, sir.
Well, I mean, I was talking to a DevOps, and a guy had a title on his card, DevOps engineer, which is like always. But
I love the directors of DevOps. I've seen more of those now. That's working its way up.
And he said that they had the hardest time, kind of, they decided to start, using Docker, but they had a heck of a time with it. This is a really sophisticated company, right? And because they were putting everything in the kitchen sink in the Docker. So sophisticated companies like this, you're having trouble with that.
Well, the truth is, I think you have to learn a little bit. So the responsibility is that the vendor says, look, given the best scenario, probably even greenfield, I can get you some value in 15 minutes. But the truth is, all that doc that HashiCorp writes when they release a product, you might want to read it. Like literally, I see people using some of the tools. I'm like, Packer does that, right? No.
The assumption is you don't need to read docs anymore.
You need to read the docs. So I think a lot of people fail to learn and say, look, before I use this thing long term, let me just sit down for just a day to go through it. And I think you'll end up being able to harvest the power of all these tools.
Maybe we just need more robots to read the docs.
That's the next level of abstraction.
Call services.
That's right. Okay, on that robotic note, thank you guys very much for joining us on this latest episode of the new Stack Analysts. And Mitchell, congrats on the new launch and your first conference.
Thank you very much.
Thanks, guys.
Thank you.
That's it for this week's show. Thank you very much for joining us. Audio editing and sound design for the new Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.